Welcome back to the 5G Monetization Forum. I hope you enjoyed the break and are ready for a number of good, impactful sessions this afternoon, starting out with our conversation around what the semiconductor supply chain shortage means for efforts to monetize 5G services. And we've got some great panelists to explore this with. I'm pleased to introduce Keith Mallinson, founder of WiseHarbor, and Neil Shah, vice president and co-founder of CounterPoint Research. Welcome, gentlemen.
Thank you for having us here.
So before we get into tying the chip shortage to the 5G agenda, which we'll also define, it's probably worth taking a few moments to kind of look back at what happened during a COVID-19 pandemic that kind of got us to where we are today. Things around consumption trends shifting, and then the assumptions that various companies made around their need for supply. But just help us set a baseline and give us some thoughts on what happened that got us to the point we're at today. Neil, maybe we can start with you.
Yeah, sure. So 2020 was an eventful year. I would say there were two major things which happened at macro level, which actually drove some significant supply shortage, right? First one was obviously the pandemic. Because of pandemic, everyone shifted working from home, studying from home, learning from home, everything from home, right? Content consumption from home. So what has happened, if you take just a few examples, like, for example, PCs, right? So before pandemic, we used to see close to 260 million PCs being shipped. But during pandemic, and you fast forward to 2020 and 2021, annually, the total PC demand has increased by 70 to 80 million per year extra, right? Which means you need 70 million more chipsets, 70 million more components, which industry never planned for. Before that, the industry was flat for last 5 years, right? So that is one example. And then you look at the broadband equipment, the demand for routers, working from home, right? You need good routers, you need good equipment. The demand for that also went skyrocket. And then you also were buying bigger TVs because you are at home and consuming more OTT consumption, right? Smart TVs and so forth. So the overall demand for electronics, and especially from home, and even on the data center side, right, almost grew double digit within 1 year. And the industry never planned for this. Obviously, the semiconductor industry, the foundry side of things, they planned for the leading nodes. So they had already investments to increase capacity whenever required for higher end processors or higher end chipsets. But what about the lower end chipsets like Wi-Fi chipsets, display driver ICs, power management ICs? Those are on matured nodes, like 28 nanometer and above. And for them, they never planned anything. And this particular event actually drove huge demand for all these ICs, because even if you don't have one IC, you cannot build a product. So that was first reason. Second reason was the geopolitics. Obviously, Huawei situation exacerbated this. Huawei actually built inventory for almost 1.5 years ahead of the time. And as a result, a lot of other competitors also started double booking because they wanted to capture Huawei's market share, because they didn't know how much Huawei had in that inventory, right? So that also exacerbated the situation. So these are the two main reasons.
Keith, I know you watch this space very closely. Any observations you would add there? And I was also hoping you might address, just because it really was maybe the most visible to people outside the telecom sector, but the impact on automotive manufacturers.
Well, yes. I mean, supply hasn't completely disappeared. So you can still buy yourself an iPhone 13 or Samsung Galaxy S22. So there is some supply, certainly, but it's been a question of who gets how much, what is available. And with a post-pandemic surging demand. So we had clearly an increase in computer demand actually through the pandemic, but with the economic stimulus, we've actually got increased demand coming out. So the top 5 smartphone OEMs actually all increased their market shares and their sales volumes significantly year over year in 2021. Clearly, a lot of that was to do with displacing Huawei, but clearly they were able to achieve that. And that's in part because they had better supply chain arrangements with more component inventory and longer term supply contracts than others. Nevertheless, Apple's CEO Tim Cook says he says he has adequate supply with advanced nodes, but not with legacy nodes. So that seems to be a common problem across the board. Apple and others said that they could have sold more devices, but for supply constraints. But components sourcing is actually a competitive advantage for them. And that's given them some pricing power that's strengthened their profit margins, interestingly. So you've got a lot of that increased demand. Look at the whole data center phenomenon. The surging demand there is a lot of silicon going there. But yeah, indeed, companies that had poorer chip supply chain management with less inventory and without a long-term supply secured have suffered enormously. That notably included the auto manufacturers and others, smaller players and such like. So when demand rebounded in 2021 with this economic stimulus and such like, they really had insufficient inventory and without the contractual commitments for supply, and that put them at the back of the line. And it was particularly painful for, I think, the car manufacturers for want of a few chips in some cases. Just a few chips out of many hundreds that are actually going to a car. They weren't even able to complete the manufacturing. There are even tales of manufacturers reverting to the old analog speedometers just so that they could complete manufacture. The auto industry was sort of more accustomed to a just-in-time kind of approach with very low levels of inventory. And Ford and Toyota, for example, are saying publicly they're still suffering from shortages. Fundamental problem, chip supply is unable to respond quickly to large surges in demand because chip manufacturing capacity tends to be rather fixed over a couple of years or more and is dependent on large long-term investments to build additional capacity.
So, Keith, you rightly point out that if a consumer wanted to go buy a 5G flagship, an iPhone 13 or an Android device that's 5G compatible, they might have had to wait a week because it was on back order, but they weren't going to go without it. We had a prep call where we were discussing the 5G fixed wireless ambitions we're seeing develop in some markets, most notably the US, and sort of anecdotal findings that there's not as many compatible CPEs as the operators would like to have on hand so they can sell this service. And I think, Neil, maybe you can expand on this idea of investment in advanced nodes at the expense of investment in mature nodes and what that dynamic looks like in terms of getting devices that people want available to them.
Yeah, that's a good point with respect to the FWA. So 5G is running out really fast, and every operator is aggressive. And obviously, everyone is looking for that killer app. Smartphones are obviously already there in terms of higher ARPU. And as you said, the demand for 5G smartphones is not that bad with respect to the chipset supply constraints, which maybe someone like Qualcomm had during 2021 first half. But it was a foundry issue from Samsung side. But if you look at TSMC, it's doing really well, and that is why MediaTek and everyone has been growing so fast in 5G space. So smartphone has not been a problem. The only issue has been, like you said, and we discussed, the routers, CPEs, those who require those like low-end chipsets, like a CPE or a router does not have Apple A type processor or Qualcomm Snapdragon in there, right? They have mostly modem or a small MCU from ST Microelectronics or NXP and all those different players. So those CPEs are all the chips which goes into CPU, all the components are on more on matured nodes. So as we discussed, like above 28 nanometer. And if you look at advanced nodes are below 28 nanometer, going up to 3 nanometer, 5 nanometer, or 4 nanometers. So the issue has been the supply from component side of things, especially Wi-Fi, which has been highly constrained. The average cost of a Wi-Fi chipset and module has gone almost 3x, 4x. So those who have more buying power and selling power, they have been able to do really well. But someone like Netgear, for example, they saw, despite demand being double digit up, they saw their revenue going 6% down because the demand they could not supply. Basically, they could not suffice. So there are different players who there are winners and losers with respect to that. But when you look at 5G monetization perspective, the FW would have been a killer app if there was no pandemic, and we could have seen more FWA rollout, more CPs rollout everywhere globally. But that was not the case because the CPs were supply constrained, and the biggest CP vendor again, Huawei, right, globally. So they could not get chipsets to supply, and the transition for someone like Vodafone or European operator from moving from Huawei-based CPE to someone like TCL Alcatel, it took almost 16 to 18 months because the design and testing with network and everything takes time, right? So that has been one of the major constraints, a roadblock for 5G monetization.
All right. So Keith, we've established here that the Apples of the world have no problem securing their supply to degrees, but there's a lot of smaller firms out there that are, making equipment that's very important to this larger narrative of digital transformation. So I'm curious, what does this mean for smaller firms, and what does the eventual kind of rebalancing look like?
Well, in the short term, I think it's difficult, and by the short term, I mean that could still be about short to medium term, certainly a couple of quarters, maybe extending a couple of years for some of these nodes. I think that it's a general problem with the pandemic is it's caused so many disruptions to the sort of balance and the continuity that there were in various supply chains. It's all been so disjointed and disconnected. I mean, just supply chains in general, like shipping, is still disrupted, and they reckon that will probably work through in the next couple of quarters. Again, because of the nature of what we have going, the structure of the chip industry with this large capital investments required, large fixed capacity, it's much more difficult for things to adjust. And you got this, for example, the auto manufacturers, they reduce production and they reduce their orders initially, and now things are snapping back in the opposite direction. So for those that haven't got themselves well lined up, I think they're going to continue to take some problems. Meanwhile, the likes of Apple and Qualcomm have announced very solid results in the last quarter. So they still say that they've been subject to some supply constraints, but actually they've done pretty well. And are probably more profitable than they would have been if let's say they're in a stronger competitive position than if supply had been more open. But I mean, I think the good news is that there is a lot of capital investment coming along that is going to sort this out eventually, and eventually maybe a year or two. Certainly before you've got general availability of everything, and that's so it all depends on exactly what you want and when. But I mean, we hear these announcements like Intel is announcing that they're going to invest 80 billion euros in European facilities over the next 10 years, 20 billion US dollars into US facilities, and Texas Instruments investing, TSMC, I think 44 billion this year and 100 billion over 3 years. So that's going to be a massive amount of capacity. But I think just as IoT really kicks into motion, then there will be supply there. But it's going to be tricky, I think, over the next year or two. The other thing that's an interesting fact that occurs, it's well known, is they have to call this phenomenon of the phony order book. In times of tight supply, customers will overorder. So you get this sort of exaggerated effect of how bad the supply constraint is. because the customers expect there to be some kind of rationing. But what happens is when supply opens up, all of a sudden, those overorders are not required, and you find yourself with excess capacity. And when there's excess capacity, that means low prices. So in the medium and to longer term, I think it's actually going to be probably a pretty good stimulus for the industry. I mean, you always have this cyclic effect in the semiconductor industry.
So it's obviously a nuanced issue, and I appreciate you all taking the time to tell us how we got here and talk to how that will kind of impact proliferation of 5G and 5G enabled projects. But really, let's make this explicit in terms of the supply chain issues and shortages and the 5G agenda. What's been established throughout the program today as about enterprise digital transformation, which is 5G, but also IoT, MEC, AI, data analytics platforms, just all things that require networking equipment, whether it's cellular or non-cellular. So just, bottom line it for our audience, does the chip shortage that we're seeing today directly and materially impact the ability for operators and all the other parties involved to put these solutions into market at scale and in a manner that helps them make money? Neil, maybe we can start with you.
Yeah, absolutely. So supply constraints is affecting across different applications which operators are looking to generate revenue from, especially in 5G era. So 4G era was more about personal transformation. It was more about smartphones and stuff, right? But 5G, everyone is looking for that, those killer applications beyond smartphones. And those are IoT, robotics, AR, VR, then you have FWA, right? So these applications does not require advanced smartphone-like solutions, right? Chipsets. So since we have supply constraints in non-advanced type chipsets, so this situation will remain for next at least a year before everything becomes a level field and the demand also slows down. But if you look at the existing demand for PCs and everything slows down, but at the same time, the demand for IoT devices, AR, VR, and everything will increase, which will require more semiconductor content, because 5G requires more semiconductor content from RF side of things, from processing side of things, from AI side of things. You'll have a lot of edge data centers also coming up, MECs coming up across the network. So everything beyond a RAN would be a data center, basically, right? It would be a different level. As you go farther away, the capacity of the data center will increase. And all data centers require chipsets, accelerators, require advanced processors for edge AI, at the same time memory as well, right? So we'll see that for this 1 or 2 years, you'll see more demand for the less advanced chipsets. But beyond that, there'll be more demand for advanced chipsets and memory even. And that is where you're seeing, to Keith's point, why Intel, TSMC are putting in like hundreds of billions of dollars in building all these different fabs and investing in advanced nodes, because this is the next wave of 5G, which is going to come of devices, which will require all these different advanced nodes eventually.
Keith, what's your take? Is there going to be any material impediment off the chip supply shortage to various 5G monetization efforts, or is it just going to be maybe a bump in the road?
Well, it is an impediment. I'd say it's more than a bump in the road. The example you gave, where I think it was T-Mobile, where they're constrained in how quickly they can roll out fixed wireless access because they lack of supply of a certain kind of chipset. Not the most advanced kind of chipset in some respects. Certainly, what's causing the impediment. But of course, it does impede the overall development of the market. And these IoT markets will take some time to get going before they are massive volume. But we need this intermediate stage to kind of lubricate the kind of the market development. So it's unfortunate. I think one other positive benefit of this is that with the advanced nodes being less problematic. I think it will encourage the suppliers to move to the advanced nodes more rapidly. Now that's a big financial commitment, but the benefit when you get there is that you have higher performance at lower cost for the higher volumes. So I think we end up in a way in a better place eventually. It's just that we've still got, it's going to be tough in the interim. And particularly if you go back to, for example, the auto manufacturers where, it's just for, you've got a car that may have like 500 chips in it. And it can be just a small number of chips that can literally stop the production of that vehicle. And you can't easily tweak the design of an entire product like that. So if you go short of something, it can be a real problem. So we're not out of the woods yet, but I think there is some sort of room for optimism. I think it does in the interim, as I said already, it does actually play, from a competitive point of view, it's playing to some of the larger players and the ones that have that leverage over the suppliers and they have the sophistication, so they may be carrying more inventory. They have longer term supply contracts, and they effectively will put pressure on the smaller players. And then, so if as an OEM, you may be a niche IoT OEM, but if you're able to use more in terms of standard chipsets from a large supplier like a Qualcomm or Intel, then maybe it's not going to be such a problem. It's at the second tier fabless chip designers, maybe they're the ones that are going to continue to be under greatest pressure for the time being.
So we just spent 22 minutes talking about chip shortages, but I did want to make note here that the Semiconductor Industry Association a few weeks ago reported full year 2021 figures, record sales, record units shipped at 1.15 trillion. So do you think what we're seeing there is the industry catching up based on pent-up demand from the previous year? And if you look forward at these long-term trends around 5G, AI, Industry 4.0, do you think that investments in additional foundry capacity are going to be able to keep pace and support this over time? Neil, can we start with you?
Sure. I think the overall, no one can deny that the demand for semiconductors is off the roof. And what has happened is the demand has also raised a lot of prices for some chipsets because because of shortage, and that is why you see the dollar ASP for per chip also has increased significantly, which has contributed to the overall revenue. So, but as we see that if you look at the Semiconductor Association revenue, it's a mix of logic and memory. So memory prices have been slightly high, but we'll see starting this year, memory prices will slightly drop until it again goes back to Keith's point, it's cyclic, especially from memory. But for the logic, for the processor, the ASP will continuously increase because the number of applications running on AI, on data center side, or the edge side, or even in the smartphones, right? It will keep on increasing, and the nanometer rates is going to go on. So the overall revenue for the semiconductor industry will keep on growing overall.
And Keith, we'll give it to you for the final word here on investment in foundry capacity as a function of supporting all these technological investments over time.
Yeah, well, as Neil was suggesting, indicated with memory, we've actually seen the prices go down, and that's as a result of in that particular case, there's been sufficient supply, and in fact, actually, Samsung's stock price took a hit at the end of last year because there was concern about the ongoing demand for memory chips. So you can actually get that occurring concurrently with this tight supply that we have on the logic side. And again, I just go back to the fundamentals here of we've had so much disruption with this pandemic and in negative ways and actually in positive ways. You know, a turn down in demand for a lot of things like cars, a surge in demand for computers, a lot of Bitcoin miners. I mean, it's a lot of silicon chips are used to mine Bitcoin. So we've got that going on, and now we've had a massive economic stimulus. We've got inflationary growth. You know, is that going to keep tearing along, or are the interest rate hikes that we're beginning to see, for example, in the UK, we had one very recently, is that going to push us back into some kind of recessionary situation? And it all varying from sector to sector. It's just very difficult for the whole ecosystem to kind of realign properly. And some sectors can realign more easily than others. The characteristic of this sector is it's these large long-term capital investments. And as we went into the pandemic, there's good reason for being kind of cautious about making ongoing investments and holding on that. And that's why you get this situation now. We've got a massive increase in growth. It looks like a very, very buoyant sort of situation, and good profits for those suppliers. I mean, that's what suppliers like to have their capacity. That's where you make profit as a chip foundry, is when you're fully utilized. Now they're hoping that this additional capacity will be substantially used as well. I think it is most likely within a few years there will be, certainly in some parts of the market, oversupply. In which case, then they won't be making so much profit. But the good thing is that ultimately, downstream for the OEMs and for the mobile operators and for the application providers and the end users, they're going to be getting high performance product at a low price, and that will further the next kind of wave of overall kind of demand growth.
Excellent. Well,
one point, maybe
we are. I apologize, Neil, but we've reached the end of our session time here. But gentlemen, I really appreciate you being on hand to share your expertise here. And a reminder to our audience, Keith's a regular contributor to RCR, so check out his work there and at WiseHarbor.com. And you can follow the work from Neil and his colleagues at CounterPointResearch.com. So thank you so much, gentlemen. I really appreciate your time.
thank you.
Thank you very much. See you in Barcelona.
Bye.